topic in Calculus 1. We want to talk about integrals involving inverse trigonometric functions. We have 3 integrals we're going to take a look at. I'll tell you why 3 and not all 6 of them in just a minute. You probably already have some thoughts on that. But I want to go back just a minute and talk about the derivative of arc sine of A. So if your function is f of x is equal to arc sine, not of A, but how about of u? Then the formula f prime of x is equal to, so remember what it is? So remember it's du over the square root of 1 minus u squared. Now, let's take a look at what we have right here. Instead of doing the arc sine of u, ru is u over a, and then of course the plus c. Let's take the derivative of that and see if we can't prove this integral by taking the derivative and see if we get that back. You ready? Alright, so ru over a is our argument, so that would be the u here. So it would be f prime of x is equal to the derivative of u over a. Remember, u is a variable and a is a constant greater than 0. So that would be u primed over a, right? Because when you take the derivative, the constant 1 over a just stays, and you take the derivative of the variable part, and that would be over the square root 1 minus u over a squared. Now if we simplify that, that would be u primed over a square root, right, of 1 minus u squared over a squared. Now continue simplifying. It's going to give me u primed over a square root. Now let's find a common denominator for this, right? That would be a squared over a squared minus u squared over a squared. Okay, let's keep going. I didn't leave myself enough room, did I? That'd be u primed over, still got that a outside, big square root of a squared minus u squared over a squared. Now, because my space is getting low, y'all, what's the square root of a squared in this denominator? Since a is greater than 0, that's just a. That'd be u primed over a square root of a squared minus u squared over a. In other words, I took the square root of the denominator, this a and this a cancel, and I get u primed square root of a squared minus u squared. And that's exactly what we have right there, or du. And so you could prove all 3 of these like this. Now, why only 3 and not 6? Well, if you'll recall, the derivative of our cosine of u was negative du over the square root of 1 minus u squared. In fact is, you don't need a positive one and a negative one. You can just handle the negative by a simple u substitution. So you don't need the arc cosine or the arc cotangent or the arc cosecant, which is great. That saves you a lot of trouble in memorizing 6 different formulas. So the rest of the video, what I want to do is just a ton of examples using these rules. So we might have to go back and check this page several different times and to see what type we have. So that's the tough part. When you see your problem, you've got to recognize the type. And recognizing the type is not always the easiest thing to do. So what we'll do is we'll come back to this page, see if we can recognize the type, or rewrite our problem where we recognize one of these 3 types, and go from there. Okay, so here's our first example. We've got the integral of dx. Listen, I've got some extra dx's going on. Should you never find an integral with 2 dx's? Let's fix that. Hold on. Does that look better? Okay, so we've got the integral of the square root of 1 over the integral of 1 over the square root of 4 minus x squared dx. Okay, now, do you recognize over here the types? I know it's teeny tiny, but notice they all have du on top. That could be your dx, but we've got to find the type. Now, notice number 2 is out. There is no square root in there, so more than likely that's not the situation that we need. Look at 1, du over the square root of a squared minus u squared. That's an arc sine problem. Remember, a is a constant. Notice that seems to be the situation we have going on, where a squared would be my 4, right? And x squared would be my u squared. So to do this problem, there's a couple of things we need to do. We need to clearly identify our a. So we could say a is 2, right? Because a squared is 4. You could even write that down. A squared is 4. That definitely means a is 2. What else do we know? There's a minus in our problem. That's good because that's required. And then u squared is x squared. So surely that means that u is equal to x. Something else we have to find is du. Just like when you have a u substitution, the derivative of u is 1 dx. Now in the future, I'm probably not going to write what a squared is and what u squared is. I'm just going to go ahead and say, hey, a is 2 because it's always the square root of that guy, and u is equal to x because it's always the square root of that guy. You with me? And I have to find du. Those are the 3 things I need to make sure I clearly note. Now, look, we have 1 dx. So we don't have anything we have to multiply by on the inside and multiply out front to compensate. Remember, the only thing you can ever do with that is a constant. Sometimes you can multiply a variable only on the inside, but you can't take it out front. Okay, but anyway, back to what we've got going on here. So there's my du, 1 dx. Okay, so this gives us the form, the integral of du over the square root. That is a squared, because 4 is a squared, minus u squared. That's exactly what we have. So that is arc sine of u over a plus c. So that's going to be arc sine. Remember, u is x, so x over a is 2, and then plus c. Now, another appropriate answer would be inverse sine of x over 2 plus c. Either one is correct. I'm going to tell you the truth. If you're doing homework in WebAssign, in one place they have this is the correct answer for a problem similar to this, and then this would be what they have as their all the way written out solution. So they're not even consistent about which one they use. If you find that you're positive it's right and you typed in the bottom one, maybe try the top one, but check your work first. I feel like they should accept both answers, but I'm not going to guarantee that because we're kind of guinea pigs using WebAssign this semester. All right, next on the list. Now remember, you've got to recognize the type. So when you look at a problem like this, does it resemble any of these 3 situations that we've got going on here? Now, one thing I do notice is number 1 and number 2, they both have a square root, right, in the denominator. Number 1 and number 3, I apologize. Number 2 does not have a square root. So this is making me think this is probably a number 2 case. Okay, now to do this, I have to identify a squared and I have to identify u squared. Now, a squared could be my 1 right there. So a squared equals 1, where u squared would equal 9x squared. Now, if I carry on, that means a is equal to 1. So I'm not going to write that anymore, but I did. And u is equal to 3x. You got to take the square root of both of them. Now, I still have to find du. So du is equal to 3. Derivative of 3x is 3 dx. Notice in my problem, here's a squared, so we can substitute for it. Here's u squared, it's substitute for it. We need a 3 dx. Look, we have a 12 dx. What am I going to do about that? Well, here's one thing I could do. I could write a 4 out here, and then on top now I do have a 3 dx, because 3 times 4 is 12, over 1 plus 9x squared. It's the same thing, right? And now substitute. So the 4 stays out front, and this is going to be the integral 3 dx. Remember, that's du. The 1 is a squared. The 9x squared is u squared. Now, formula for that, well, that's 4, just comes across, right? And this is going to be 1 over a. Now I'm just following the formula. Okay, so I'm using this formula right here. It says 1 over a. Well, y'all, what's a? 1, right? So that's going to be 1 over 1. And then arc tangent of u over a. Now what's u? It's 3x. What's a? 1 plus c. But we need to make this look better. So how about 4 arc tangent of 3x plus c? Final answer. That's my integral. Alright, so here's c. The integral of 7 divided by 4 plus, all in parentheses, 3 minus x squared dx. So why don't you pause it, see if you can figure out which type it is, find out what a is, find out what u is, and go back and substitute and see if you can calculate this indefinite integral. So how'd it go? I'm seeing that there is no square root down here, so that tells me more than likely we're dealing with a number 2 situation, which is an arctangent problem. So let's label everything. In this case, it looks like a squared would be 4, which would make a 2, right? Your u squared would be 3 minus x squared, which means u would be 3 minus x. You also have to find du, which is negative 1 dx. We just took the derivative of u to find du, right? Now for our substitution, we have the integral. Now 7 dx is not what we need. We need a negative 1 dx. Can I do that? Sure I can. I don't want that 7 there. And anytime you have a constant, you're multiplying by a constant. So this whole fraction is like times 7. You don't want that constant there. You can pull that out front. Now, if it was a variable, you could not do that. Only with a constant. Now, that leaves me with just the dx. Okay, but how do we do the negative 1? Well, I can put a negative 1 in there if I want to, as long as I compensate by putting a negative 1 out front as well. And I'm just going to put the negative. Now, in the denominator, we have, I'm just going to say 4 plus, I'm just going to rewrite, 3 minus x squared dx. Now, you tell me, is this identical to what we have here? Well, no, you say it looks different. Well, it is, but it's the same value, right? This negative 7 times this negative 1 gives me positive 7 back. Now, when I make my substitution, I'm not going to substitute for anything out front. That stays negative 7. But this is du. Oh, look, I have 2 dx's again. Looks like the thing of the day. So this is du on top. This is going to be a squared plus u squared. Then for sure, that's an arctangent, right? So now I have negative 7 times 1 over a. The negative 7 was just out front. Now I'm using the formula. So 1 over a, what's a? 2, right? And then arctangent of u over a, what's u? 3 minus x. What's a? 2 plus c. Then you make it look better by saying, hey, that's negative 7 halves. Arctangent of 3 minus x over 2. Or the parentheses might look better around the whole thing rather than just the numerator. So maybe this, 3 minus x over 2 plus c. And that is the correct answer. Now, you could also write negative 7 halves inverse tangent, the tan with a little negative 1, a 3 minus x over 2 plus c. All right, next, can we recognize this type? And when you look at it, the first thing that I look at is I notice there's a square root. So that more than likely knocks out the number 2 option, arctangent. And look at this too. Notice how it's variable and then minus the constant. So that would point away from the arc sign and more towards the arcsecant. See how the arcsecant is u squared minus a squared? So it looks like u squared, it might work out if u squared is x to the 4th. And a squared might be 4. Okay, so u squared minus a squared, which would make u equal x squared, which is the square root of x to the 4th, and it would make a equal to 2. Don't forget, you still have to find du. Now, du is 2x dx, right? Just the derivative of u, and it's the derivative of u with respect to x, so we move the dx to the other side. Now, when I'm looking at this, I don't have a 2x dx. What do I have? I have a 7 dx. What can we do about that? Well, the first thing is I don't need that 7. Okay, so folks, I'm going to pull that 7 out. So it's going to give me 7, the integral, and that leaves me with a dx. And on the bottom, I have x square root of x to the 4th minus 4. Now again, remember what I need? I need a 2x, right? Now watch this. What if, just what if, I multiplied by 2x over 2x? Okay. Now on the top, that would give me the 2x dx that I need. There is my du. But on the bottom, do I have what I need? Well, what's supposed to be out front here, notice, is just u. Well, what is u? Well, u is x squared. I don't have an x squared, I have an x. But look, if I multiply this by this 2x over 2x, I now have an x squared. So watch this, I'm rewriting again. Okay, so we know that on top here, that 2x dx is what we need, that's du. On the bottom, I'm going to move this 2x in front, that's 2x squared, square root of x to the 4th minus 4. Now let's compare. I do have du on top, exactly what I need, that's du. On the bottom, I'm supposed to have u times the square root of u squared minus a squared. U is right here, and that is the square root of u squared minus a squared. So I have everything I need in yellow. What I don't need is that 2. What could I do with it? How about I pull it out front, right? It's a constant multiple. So it's going to give me 7/2, the integral of that's du over, and that's u squared, square root of u squared minus a squared. And we know from the formula that's going to be 7/2. That's 1 over a. Look, I'm looking at my formula here. 1 over a. What's a is 2. And this is going to be arc secant of the absolute value of u. What is u? X squared over a, which is 2 plus c. Now I simplified this as much as possible. So in the front I have 7/4, right? And this is arc secant. Now the absolute value of x squared, y'all, is just x squared. X squared is already positive. I don't need absolute value. Over 2 plus c. And if you could put parentheses around that, you can. You don't necessarily have to. What do you think? Not bad, right? It took a little work, though. We had to do a little adjustment on this. Had to do this fancy trick of multiplying by 2x over 2x. But magically, when I did, I had everything I needed, except that extra 2 in the bottom, and I just pulled that out front. You can always pull a constant multiple out front. You cannot pull addition and subtraction out front, and you can't pull any variables out front. Okay, so we've got e. What do you think about this one? Please notice it has a square root. Okay, so we're probably talking 1 and 3, although you could probably come up with an arctangent problem that might have a square root in it, so be careful before you're quick to judge. Make sure the rest of it follows in line as well. I lean more towards the first one. Why? Because it's a squared minus u squared, with the constant first minus the variable. Notice for arc secant, the variable comes first minus the constant, and it's also got a variable out front. Now you might be thinking, hey, this has got a variable out front too, so how do I know if it's arc secant or arc sin? Well, don't be too quick to judge until you guess your a, you guess your u, and you find du. Okay, so we're guessing that our a squared is 1, which would make our a equal to 1. Our u squared would be natural log of x, which would mean our u, natural log of x squared, which means our u is natural log of x. Now don't forget you have to find du. What's the derivative of natural log of x? Well, that's 1 over x dx, right? Now locate your 1 over x dx. So that's 1 over x dx. So highlighted in green right there is my du. So it means the rest of this, if I make my substitution, is going to be the integral of, we already decided that's du, let's write it on the top, the square root of 1, that's my a, right, a squared, minus natural log of x is u, so that's u squared. So clearly that is an arc sin problem. So my answer is arc sin of u over a plus c, so that's going to be arc sin of u over a. Now remember, u is natural log of x over a is 1 plus c, which is arc sin of natural log of x plus c. And I like parentheses around my my inside of my arc sine. Another correct answer would be inverse sine of natural log of x plus c. They're both right. They're both saying exactly the same thing, just different notation. Alright, so for example F, we've got the integral of 5 divided by x square root of 9x squared minus 11. Now once again, notice the square root in the denominator. So that's saying that maybe we need 1 or 3. Is this an arc sine? Is this an arc secant? Or is this some kind of tricky arc tangent and we don't understand what's up with the square root? Well, once again, notice that the variable part is first minus the constant part second. So that's saying maybe this is an arc secant problem, right? And then let's just get it set up. So you start with the inside. What would u squared be? Well, u squared would be 9x squared. So if I take the square root of that, it would be 3x, right? That means a squared would be 11. If that's worrisome, don't let it be. That means a is the square root of 11. Is that okay? Sure it is. Don't forget you have to calculate du, okay? So du is derivative of 3x. It'd be 3 dx. Now let's look at our problem. So first of all, we don't have a 3 dx, we have a 5 dx. What can we do about that? Well, I don't like that 5. Let's move it out front. I can always do that when I'm multiplying by a constant. What does that leave me with inside? A dx, okay? And then in the denominator, still have an x in front, and 9x squared minus 11. Let's keep thinking. Now, if I want a 3 in there with that dx, can I do that? Sure I can. I put a 3 in there, and I put a 1/3 out front. In other words, I just multiplied by 3 over 3, but the 3 in the numerator inside my integral, the 3 in the denominator outside my integral. So far, so good. So now I have a 5/3 in front. Now let's do all our substitution and see if it works out. This 3 dx is du. All right, now in the denominator, notice that I'm supposed to have a u in front of my square root. What is u? U is 3x. Wait a minute. I'm supposed to have a 3x there. Hey, don't I need this 3 inside? Can I move it inside? Sure I can. So let's don't have it out here. Let's have it back in here. So that 3 is inside. So there's u. And you have the square root of u squared, because 9x squared is u squared, minus a squared. So notice that's in the exact form of arc secant. Now I'll just use the formula. And that little old 5, he's still hanging out. There's 5, and that's the integral. Let's don't write the integral anymore because I'm ready to use the formula. So 1 over a, so it's going to be 1 over, what's a? Right up here, square root of 11. All right, arc secant of u over a, so the absolute value of u is going to be 3x over a. A is still 1. That was not, it's the square root of 11 plus c. Now I can make that look a little bit better. So this is 5 over the square root of 11 in front, and then arc secant or inverse secant of the absolute value of 3x over the square root of 11 plus c. One more thing. I could rewrite the absolute value of 3x as 3 absolute value of x, because 3 is positive. So this is the simplest I do believe that will get. Alright, so now we have a trig function to deal with. And when I'm comparing the 3 over here, so first of all, what I really need to be doing is looking at this and going, can I handle this any other way? Like often, when you have an integral, you let u be the denominator. But y'all, if I let u be 7 plus cosine squared of x, and I take the derivative of that, I'm not going to get sine of x dx. I don't want you to get in this section and only think about these 3. I mean, that is what's going on. But when you start just taking integrals in general, you need to be thinking about all the rules you know, because it's not going to be per section. But in this section, clearly, it is just one of these 3. Maybe, anyway. This one is, but I just want you to think about all of the old ways to take integrals too, because that may apply before you ever get to something like this. But no way can I let u be one of these and end up with the other part. So I'm looking at this one right here. Why could that work? Well, first of all, there's no square root, so I'm thinking it's probably not 1 or 3. And a squared would be the 7. That means a is the square root of 7. Again, it's okay if your a or your u is not perfect, especially the a. Cosine squared of x is going to be your u squared, which means u is equal to cosine of x. And du, what's the derivative of cosine of x? Well, the derivative of cosine of x is negative sine of x dx, right? Well, look, we don't have a negative sine of x dx. We just have a sine of x dx. Can we fix that? Absolutely. We're just going to throw a negative inside and a negative out front to compensate. So what we have going on now is negative the integral. Remember, on top we have du. We've already established that. And the bottom we have a squared plus u squared, which is definitely an arctangent. That's negative 1 over a. So I'm looking at the formula. What is a? Square root of 7. And then arctangent of u over a. So cosine of x over the square root of 7 plus c. And you are taking the arctangent of that entire expression. Cosine of x over the square root of 7. I guess one extra thing that I should point out just in case. I'm certainly comfortable with this answer, but I have noticed that some answers that have a constant multiple in front with the square root in the denominator, they rationalize. So you may see this answer as negative the square root of 7 over 7. But now the argument over here, cosine of x square root of 7, they left that as is. Okay? So I'm perfectly comfortable with either one. But if you're doing online homework, you may want to go ahead and rationalize that constant right there. Now this guy looks a little different. Maybe you want to pause in a minute, see if you can think through this. Now here's what I notice when I look at this. There is a square root down here, but it's not, you don't have addition, or subtraction. Notice it's addition, so that's telling me maybe this is an arctan problem. And don't let that square root throw you off. And can we find an a squared and a u squared? Let's see what we can do. This looks ugly, but we can handle it. So what if we let, okay, this would be a squared plus u squared. You see where I'm getting that from? It means a squared would equal 1, which means a is 1. U squared would equal x. Hold on, that means u is equal to the square root of x. Is that okay? Well, let's keep going. So du is equal to, well, we got to take the derivative. So maybe let's write this as a rational exponent. So it's going to be 1/2 x to the negative 1/2 dx when I take the derivative. So all of that is du. So first of all, I don't see a 3 anywhere. When I'm looking up here, there's a 3. When I'm looking down here, I don't see a 3. So let's move that 3 out. So it'd be 3 integral. All right, so the 3 is out front. Now look. This 1/2 x to the negative 1/2 could be rewritten as 1 over 2 square root of x dx. Am I right? So highlighted, that is du. All right, which means that's a squared plus u squared. So I've got du over a squared plus u squared. Remember the 3 came out front. There it is. What's highlighted there, 1 over 2 square root of x dx. That's du. I just wrote it on the top. And I'm left with 1 plus x. 1 was a squared. X was u squared. So this is straightforward arctangent problem. So this is 3 times 1 over a. What's our a is 1. And then arctangent of u over a. And it's in absolute value. My u is x, my u is square root of x, okay, over a, which is 1 plus c. Simplified, that's just going to be 3 arctangent. Now, I don't have to write these absolute values around the square root of x. Why is that? Because square root of x is always positive, plus c. And that is my final result for my integral. All right, so now we're getting to the maybe slightly challenging problems. When you look at this denominator, first of all, again, just think basic u substitution. If I let u be what's underneath the square root, x squared minus 4, am I going to pick up all the rest of this? And if the answer is just straight up no, right? I can't distribute this x inside, because you can't distribute the x inside of a square root like that. That's not going to get you what you need. So maybe it's one of these three, but it's not looking like it, right? Because you've got this x squared plus 8 up top, which could be a problem. So here's the suggestion. We'll just see if it works. I've got the integral of x squared. What if I just put that over x times x squared minus 4? That's an x squared, by the way. And then, separately, that's a dx that goes with that. Separately, I add the integral of 8 over x times the square root of x squared minus 4 dx. Can I do some stunt like that? Well, sure. You're just splitting your fraction. If I added those two back together, I would definitely get this back. Now, will that give us what we need? Well, what I do notice is right here, these two guys will simplify. So that gives me an x on top. So now I have the integral of x over the square root of x squared minus 4 dx plus 8 over x square root of x squared minus 4 dx. Now, did that help? Well, for this particular integral, just this integral alone, I can do a plain old u substitution. Remember, you're going to let u be the inside, which is x squared minus 4. du is 2x dx. Now, I don't have a 2x dx. I do have an x dx right up top, right? How do I get the 2 in there? I put a 2 here and a 1/2 out front. So that turns into 1/2 the integral, okay? That's going to be du over u to the 1/2, which can be written as, forgive me, I'm going to erase for space, u to the negative 1/2 du. We know how to find the integral of that. This problem is one of these guys right here. Notice it's variable part squared first minus constant squared. So this is an arcsecant where the 8 comes out front. We don't need it. So it's going to be plus, okay, but let's let u squared is equal to x squared, which means u is equal to x. A squared is equal to 4, which means a is equal to 2. Remember, I still have to find du. Derivative of u is 1 dx. So that gives me the form of the 8 out front. And this is du in the numerator, which is 1 dx, because we already pulled the 8 out. And then this is u, right? Square root of u squared minus a squared. Let's keep going. I find the antiderivative of u to the negative 1/2. I add 1 to that, so that's u to the positive 1/2 divided by 2. So there's a 1/2 in front, and positive 1/2 actually multiplied by 2 because I'm dividing by 1/2, so that's 2 over 1, u to the 1/2 plus 8, and this is arcsecant, right, of u over a, in absolute value, u is x, so the absolute value of x over a is 2 plus c. Now I'm not completely finished because this 2 cancels with this one, and I have to plug u back in for the first integral, which was x squared minus 4 to the 1/2, so that's the square root of x squared minus 4 plus 8 arcsecant absolute value of x over 2 plus c. That one was a doozy, don't you think? And when I circle my answer and move on, I always try to check my work and listen, I noticed something. Maybe you did too. The formula for arcsecant. The 8, remember, was in front of the integral. We have to do 1 over a. I left off the 1 over a, so this is times 1 over, my a is 2, which is going to change that 8 over 2 to 4. So we have the square root of x squared minus 4, which was my u over here, plus 4 arcsecant of absolute value of u over 2 plus c. So this looks more like my official answer. Apologize for that. Okay, folks, I have 2 more problems I want to show you. Notice the directions say find the indefinite integral by completing the square. This, when you look at this form, the first thing you're supposed to think of is Can I integrate it as is? Well, no. Can I do a u substitution? Well, if you let u be the denominator, which is the going rate of doing a u substitution, your du would be 2x plus 4, and we do not have a 2x plus 4 up top, and we can just easily make a 2x plus 4 and turn into a form that we can integrate. But now, none of these three look viable in the situation that we have going on here. But there is a method to maybe help turn a polynomial in the denominator, or a square root of a polynomial in the denominator, to fit one of these patterns. Now, there is no square root down here right now. So what we're shooting for is to make our integral look something like this. But we don't have two perfect squares that we're adding together right now. So the technique is to complete the square. And you've probably learned the method of completing the square in various courses along the way. But if you haven't, I'm going to show you. The first thing that I do is group the x squared and the x term together. Okay, so I'm thinking about those together. The 8 is just going to be kind of hanging out by himself. So I'm going to just rewrite this problem as dx over, and in parentheses I've got x squared plus 4x, then leave some space and just put that plus 8 on the outside. Alright, now the next thing you would do is factor out the leading coefficient. Well, I guess first thing you would really need to do is see if this is a perfect square. If you factor that, would that be a perfect square? Multiplies to be 8, adds to be 4. It just doesn't even factor. But check that first before you start doing all this. Now, the leading coefficient is 1 in this case, so it's not going to have any bearing on the next step, okay, or steps. But you would factor out a leading coefficient. If there's a 2 right there, you'd have to factor it out of both of these terms. Now, the next thing you do after you factor the leading coefficient is you find half. I should say half. Let's try this again. Find half of the x coefficient and square that value. So I should say then square it. Okay, so that'd be half of 4 equals 2, and then we square it. 2 squared takes us back to 4. Usually it's not the same value as you started with, but whenever you're dealing with 4, that's the case. You add that inside, and is very important, subtract the leading coefficient times that number on the outside. Okay, now remember our leading coefficient is 1, so we didn't have to factor out a leading coefficient. So I'm going to add that number, that 4 on the inside, and subtract the leading coefficient, which is 1, times that 4 on the outside. And let's see what we have after we do all that. Okay, so we have the integral of dx in the numerator. That's going to give me x squared plus 4x plus 4. Now that factors into a perfect square. It's x plus 2 times x plus 2, or x plus 2 squared. And then the 8 minus 4, not 14, this is multiplication. 8 minus 4 gives me plus 4. Now what we have here is an equivalent value to what we started with. If you multiplied all this back out, be x squared plus 4x plus 4, you'd add the 4 plus 4 to get 8. So this is an equivalent polynomial in the denominator as what we had earlier, just written in a different form. But if you'll notice, this is an arctangent integral. So your u is x plus 2, okay? U squared is x plus 2 squared, your u is x plus 2. Your a value is 2. In other words, the square root of 4. So your answer is 1 over a, which is 2, arctangent of u over a, so that's going to be x plus 2 over 2 plus c. And there is your integral. So I've got one more of these I want to do that's actually a definite integral, and then we will call this section done, and actually we'll call the whole course done. Okay, so for our very last problem, let's see, evaluate the indefinite integral this time. This is actually not an indefinite integral at all. It is a definite integral. I forgot to fix that, by completing the square. Now, if you, again, look for the type. Like if I let u be x squared minus 2x, which is often what you do, either let u be the denominator or let u be what's under a radical, then you would get 2x minus 2. So we could do this one a different way. But let's follow what it says. It says by completing the square. Okay? So this is definitely not in any format we have over here, although I have a square root. So we're either thinking this one or this one in the denominator. But notice how the variable part is first, but we don't even have a constant second. And that's why we need to complete the square. We have the x squared part, which is looking more like this situation. Right? We have the u squared, which would be x squared, but we don't have the constant. But maybe we could write this as a perfect square and it would turn into this format. It's just something you could try. Alright, so I'm going to complete the square. So this is just scratch work for x squared minus 2x. Okay, so remember the first thing you do is you group together the x squared and the x term. Well, that's all we have in this case, so there's my parentheses. You factor out the leading coefficient, which is 1. So a 1 would get factored out of both of these, but that gives you the same thing. You take half of negative 2, which is negative 1, and then you square it. And this is the value you want to add on the inside and subtract the leading coefficient times it on the outside. So it's 1 times x squared minus 2x. Again, I'm adding 1 on the inside, and I'm subtracting the leading coefficient times what I added on the outside. Now, my new integral is going to be the integral from 1 to 4 of 1 over x minus 1, and then we have the square root of, now let's factor this, okay, it should be a perfect square, so it's going to be x minus 1 squared, and then that's going to be minus 1. Now, this suddenly looks just like your number 3, your arcsecant problem. So I'm going to let u equal x minus 1, whereas a is equal to the square root of 1, which is 1. Don't forget to find du, which is 1 dx. Notice I forgot to write the dx, but we do have a 1 dx. We don't have to fix anything. So that turns into the integral of du. There's a u right here, and square root of u squared minus a squared, which is exactly what we need. So when I substitute in everything, I've got 1 over a, which is 1, arcsecant of the absolute value of u, and they are required in this case, over a, which is 1. Now we don't add plus c because we have a definite integral from 1 to 4. So I'm going to plug in 4 first. Of course, this is just 1, so I have arcsecant of absolute value of 4 minus 1 minus the arcsecant of the absolute value of 1 minus 1 over 1. So this is the arcsecant. Let me rewrite that where it's a little more legible. This is the arcsecant of the absolute value of 3 minus the arcsecant of absolute value of 0, which is really the arcsecant. You don't need the absolute values around a positive number of 3 minus the arcsecant of 0. And in fact, it took me to the end of this problem to realize that I made an error. It's just a typo, not in the solution. But you actually can't evaluate the arcsecant of 0. If you think about what that is, you're asking yourself, arcsecant, you're asking yourself, where is secant of theta equal to 0? The secant is 1 over the cosine of theta equals 0. That can't happen because you have a 1 in the numerator. That's impossible. And then I thought, what's going on? But I have a typo. This was supposed to be a 3. So to fix that, that would make this value a 3. And when we plugged in 4, that would make that value a 3, and that value a 2, and that value a 2. Now what do you do next? You plug that in your calculator and come out with the answer. Now arcsecant would be 1 over arc cosine of 3 minus 1 over arc cosine of 2. And then that will give you your final answer, which is 0.1838. Now let me know if you have any questions about that. Those are clearly not nice numbers, so that was something you would have to substitute in the calculator. But the really important thing there is I wanted you to realize the method of completing the square on these problems. And sometimes that's just what you have to do to get into the right format. Sometimes it works and sometimes it doesn't. So I hope you have a great day. I hope you got a lot out of this course. Please let me know if you have any questions at all.